Okay, so I'm Flora, for those who do not know me. I'm new to Fybrik as well. Alexei and me joined in the beginning of this year. And I'm in IBM for 21 years in IBM research. So the goal of Fybrik is to unleash the power of data when it's spread over a multi-cloud and hybrid cloud environment. It's a cloud-native platform that unifies data access and enforces governance. And by that, it frees the business or the enterprise from taking care of these aspects. It's an open source project. And these are the main users that in Fybrik Vision we address. Currently, what is currently developed is for the three here. You see my mouse? For the three first, the data user, the data governance, and the IT admin, but there is a vision also to support data engineering. So I'll go one by one. So for the data user, for example, a machine learning scientist, Fybrik automates the need to get approval to use data. It automates the need to get credentials, and also it helps the access when the approval is already received. For the data governance officer, which usually sometimes he needs to enforce his requirements, and it's more a recommendation than the real process. So Fybrik automates the governance enforcement and captures a proof of concept or proof of the enforcement for auditing. So currently, when I'm also explaining about Fybrik, I'll also mention what is already implemented and what is less developed or less tested. So for auditing purposes, for governance, we still do not have a solution. We do have a solution for enforcing governance. For the IT admin, Fybrik optimizes the workload data path and orchestrates the data path. That's the main thing that I'll present soon. It helps doing the caching, the optimization of where to move the data, if to move the data, and more. And it frees the IT admin from having to do these things manually, the deployment, the monitoring. And for the next step that is part of Fybrik Vision is to automate tasks such as lineage and quality. And we do currently already update data catalogs, and that's something that's already exists. So let me jump to this slide. I hope you can see all of it. So Fybrik is an open architecture. It can enable others to contribute and add functionality as they need. The Fybrik core includes an orchestrator that has connectors to different functionalities. It has currently 3 main connectors, but we are adding more. So we have a connector that takes care for the credentials. A credential manager could be Vault or Kubernetes Secrets or What's on Knowledge Catalog or others. We have a connector for data catalog. Currently, we have 2 connectors for What's on Knowledge Catalog, IBM offering, and for catalog that we use for testing. And we are currently looking at other data catalogs, open source catalogs as Amazon and Data Hub and others. The third type of connectors is for the data governance policy manager. We have, once again, a What's on Knowledge Catalog connector for the policy governance. And we have OPA, which is a standard open policy agent standard connector. So the Fybrik core connects with each one of these connectors in order to get the credentials, the information about the data asset, and the policy needs to be enforced. And that's one input. And the second type of input is the different modules, Fybrik modules that are available for building a data plane. For example, a write model, a read model, a copy, a transform model. And when knowing all these models that are available for use, Fybrik orchestrates and builds a blueprint, and using a plotter that defines what would be the data, the best or an optimal data plane for a specific workload. I'll explain more. So the decisions that Fybrik needs to take when it creates a data plane, it depends on which capabilities the user application needs, if it's a read, a write, a copy, and what models exist, transform, data quality, etc. It needs to know where should each capability run. Should it be close to the data? And in that case, we will need to copy data from one place to another. We might need to copy data. Should it be close to the workload? Should it be on the same cluster because of a geography constraint? So taking these questions into account, and what is the preferred deployment approach for each capability? Should it be deployed by Fybrik per workload or per dataset, or it's a pre-deployed multi-tenant service that can be used for multiple workloads? Taking all these considerations into account, Fybrik needs to enforce the policies, the governance policies, IT policies that might look into the bandwidth and the storage costs and other considerations, and come with as an output with a data plane. Let me jump to an example of data plane. So here we have an example of 3 different data paths for the same workload and same request. So we have an application, for example, that wants to read data, and part of the data must be masked according or redacted according to a policy that was defined. And there are 3 different options, and there are more, but these are 3 options how to address the workload. So we have the data on another cloud, the application user is on a different cloud, and the first diagram, we put a Fybrik model near the data. This Fybrik model accesses the data, transform, reducts the columns that need to be masked, and then sends the data over to the application. In the second diagram, the Fybrik model is in the same cloud, same cluster as the application, and the access and the transform is done near the application, near the workload. In the third diagram, we have 2 Fybrik models involved. One of them is doing the copy, and the copy is near the application. In this case, if we have the compute power near the application, we would like to have the data near the compute power. So we will have a copy. This is an expensive solution, but sometimes that's the best optimal solution for a specific workload. And then we have a Fybrik that only does the access. So these are examples of the output from Fybrik. Any questions so far?
Sorry, I may have missed this, but does this only touch the data access, or does this also work on observability?
What do you mean by observability? You mean lineage? Monitoring?
No, so you see, the problem fundamentally is when we start to build data catalog, is we have to start maintaining all information about the catalog, and so that generally results in 2 type of access rights being managed. One type of access at the catalog level to discover the data. Another is the actual data source that needs to be integrated or federated or replicated if you have a data pipeline. And so fundamentally, this is where we basically waste a lot of time, and we have security and compliance issue. So what I'm trying to understand is that, does this layer that you have work in a typical scenario where I may have like 20 different data sources that are federated? And then based on this compliance access, when I actually go and query, oh, what data do I have in the enterprise, it will only show 10 or 12 of them because those are the ones that are accessible to me in my profile.
So the question is, do we do this enforcement on the data catalog already stage when accessing the data catalog or the data itself?
Yeah, more, yes, when you are discovering the data or when you are querying the data or both.
It is open, it is in the way that you configure Fybrik. If you would give Fybrik access when you configure it, or the IT configures Fybrik application to have access to the data catalog with information about all these 20, then you will see all these 20. If you don't, then we don't. The vision is that enterprise would put Fybrik between the 20 data sources and the many applications. So once it is in between, it should have access to all the data that is cataloged in a specific catalog. And then it would show everything.
All right.
So it's
Vincent, actually, this scenario is that demonstrates access mostly, and it's from the slide because it's something.
yes. Oh, you're not seeing this slide?
Yeah, here, yes, and maybe the difference between all three, it's based on on the policies of, for example, we have restrictions that sensitive data can go out of a specific geographical location. So if you see that the example in the middle, okay, we can copy it to we can restrict or mask the data on the local cloud, local deployment, local data center, but it will violate requirements. It's actually the full data is going to the outside of geographical location, and here we just mask it. Of course, user will get the right data set, but strictly checking it, we have violation. And two other scenarios we can prevent it. For example, on the first one, we don't have, we can mask locally. And the third one, we can optimize to provide low latency. We can first we can mask it on the remote data center, and after that go to the copy the reduced data set to the local location, and here the application will have it with low latency access. So it's different scenarios.
All right, yeah, got it.
And of course, all this configuration is done by OPPO Rega policies. It's not changes in the code. It can be add or remove. It's external configuration and specific for it's OPPO. It's very powerful tool, so we can define a lot of different configuration or constraints and whatever we want.
So maybe I go back to this slide in order to emphasize what Alexei just said, that Fybrik is configured it's outside, it's not hard-coded. So it's configured through the policies, through the workload YAML, and the policies to ensure IT demands.
Yeah.
Okay, I think that's in essence what is Fybrik. I can continue more, but I think that already explains. And if you have more questions, please.